All right, well, welcome back. We're going to talk about how to use and find the linear square regression line again, and how to use a residual plot to determine what is whether or not a data is linear or not. It could be used for a linear model. So without further ado, first thing is what we have is fuel economy given by in 1984, the table of city and highway miles fuel economy for a range of vehicles for 10 vehicles in 2021 vehicles are here. So city fuel economy miles per gallon, highway fuel economy miles per gallon, and what we have is this we have here, followed by this what we have here, and we want to plot to see this data. So first thing, if you go to stat, go to edit, and you want to plug in your X values. So right here, we want to see if fuel economy gives the city and highway miles for all makes miles back in there. We have a table, and we're going to say that this right here, our explanatory variable, this is going to be our X, and this is going to be our response, and this is going to be our Y. All right, Y hat. Okay, so in our list one, we're going to put all of the city fuel economy right there, miles per gallon. So if you put those in there, and that's what I did there. And for list two, you're going to put in your Y hat or your explanatory, your response variable values that are appropriate for each one. After doing that, you go back to stat, and you want to calculate. And once again, we're going to go down to 8. We're going to figure out the linear regression of A and BX. So we're going to push in 8 here. It's going to say list 1, list 2. Yes, list 1 is our X values. List 2 is our Y values. We're going to go down, and we're going to calculate this, and bada bing, bada boom, and here we have it. So in this problem, okay, we're going to say that y hat is going to equal our y-intercept of 0.0 or 6.084, and we'll add that to our slope of 1.264 x, and we see where x's are going to be, and that's how we have that. We see an r squared value of 0.841 and an R value of 0.917. Now, we can see that our R value, that these are fairly close. And if you look at our data right here, because we're going to see, is this appropriate? Does the residual plot of the data shown, what does the residual plot indicate about the appropriateness of the linear model? Okay, explain your answers. Now, if you see this, you can see that this is kind of going up and down, and it appears that there is some sort of pattern here, all right? Some positive and negative and positive and positive and negative, and it kind of goes in this little pattern right there. And it does not appear to be, at least for me, linear. And so what we would do, because there is a pattern, or there appears to be a pattern in the residual plot, all right, of city fuel economy. All right. Because of the pattern in the residual plot for the city economy, a linear model may not be appropriate yet, and that's what we know. All right, and that's what we're looking for, because it goes up and down. If I kind of graph it, it kind of looks like this. All right, and we have that 1 point right there, but it looks like a pretty good pattern right there. So that's what would be my indication. All right, and that's it. That's what we're looking for. We can always find a linear regression given to quantitative data samples, and we can find if there's an association. Okay. However, we want to look at the residual plot to determine if there actually is going to be if this data actually resembles or would be best be modeled by a line. All right. Well, I hope this helps you out, and good luck and God bless in the rest of your problems.